Alrighty, we're on to 17.2. We're going to start looking at the last type of transformation for our parent graphs for sine and cosine. We're going to look at a vertical shift, so taking a graph and moving it either up or down. So being able to see what that looks like and where those go in our equation. So I'm going to have you think back again, kind of a warm-up question here, to a parabola. So just like a regular x squared, which is our normal U-shaped graph. So we'd have these points 0, 0, and 1, 1, negative 1, 1, graph that looks like this. So that would be our parent graph. What if we did something like this, y equals, and then we had x squared plus 3? What would that do to your graph? What do you think? What's your hunch? Well, if our point was normally at 0, guess what adding 3 to it would do? Well, it would make it 3 higher. So it would move up 3. This point that was at 1 would go up to 4. The point that was at negative 1 would go up to 4 as well. And it takes the entire graph and it shifts it up 3. So guess what doing x squared minus 3 would do? Well, that would take the entire graph, all the points, and move it down 3. So this idea of a translation, translating is just like a slide, a shift. The shape is the same. So it's the same size and shape. It's not like what we were talking about with those making it taller or stretching it out in the horizontal direction. This actually maintains the same size and shape. They call that congruent. It's exactly the same size and shape. You're just lifting it up and sliding it somewhere, either up or down. And you can also slide these graphs actually left and right. You can do horizontal translations as well. We're not going to be talking about that in this course, but you definitely can do that as well. So that's our plan. That's what we're going to be looking for. All right, so we've got lots of information here to talk about. So how are these equations different? So we had the a sine of bx or a cosine of bx in our discussion with amplitude and period. Now we're going to look at this c value, which is that vertical translation. And just to be aware, you can write it with the c at the end as well. So I'm going to write sort of the other version of this just so you can see, pun intended, what the c looks like at the end. So you can also have it there because remember your order that you add two terms doesn't matter. So you can do the c either at the beginning or at the end. That's sort of personal preference and how you like to write things. So we talked about what the a and the b do, but let's just do a quick refresh on that. The a is an amplitude, so that's going to tell you that height of the curve. Remember the distance from the middle to the top or the middle to the bottom. So that's that number that is multiplied with, so be very cautious on that. It's the one that's actually multiplied. It's that vertical stretch and compression. Remember, it's always a positive number when you report back actual amplitudes. When you say, hey, the amplitude of the graph is, that's always a positive number. But remember, if the a is negative, so take a peek, a is less than 0, that means negative. That means the graph is reflected over the x-axis. So if it was starting at the middle and going up, the graph would be starting at the middle and then going down. Or like for a cosine graph, it was starting at the max, it would now start at the min. So it reflects over the x-axis. So amplitude is that height of the curve. And the b value, remember what b affects? The b value, that affects the period of the graph. There is a calculation involved to calculate period. So this b value, this number that is multiplied with the x on the inside, part of the angle measurement, is talking about that horizontal stretch or compression. So the formula for period, very important. We have to actually do a calculation here, is 2 pi, the regular period of the function, divided by b. And remember, another way to think about b, it's the number of complete cycles you see in 2 pi. So if b is 1, you see that 1 cycle. If b is something else, it's going to make it either longer or shorter to get through 1 complete cycle. So those are the two things we already talked about. So now let's talk about c. So ABC. C is your vertical shift. So the c value, again, is the one that's being added or subtracted, either at the beginning or the end, doesn't matter. And the sign of it will tell you what the graph is going to do. So c is that vertical shift, the constant, if you want to think of it that way. So if the c is positive, like plus 7, plus 12, plus 15, the graph shifts up c units, whatever c is. So the graph is going to go up whatever c value is. And guess what? If the c is negative, then the graph shifts down c units. So whatever c is, that's how far the shift is going to be. So if it was like minus 12, I would be going down 12. So it's almost like the entire graph is shifting. So what we really think about is where does the middle go? Where does that x-axis, that middle of the graph go if we're shifting up or down? So it's really nice to think of this kind of horizontal line, y equals c. We call it the midline, the middle of the graph. And this is going to be something that's going to help us graph and see what that picture looks like. So we're going to be looking at that horizontal line to sort of ground where our picture is going to be. So it's like the entire graph is moving, so it's almost like there's a new x-axis that we're connecting this graph to. So we're going to try a couple and see how we're feeling about these different graphs. So we're going to do all our identifying first. What are our A, B, and C values, and how does that affect our graph? And then we're going to actually see if we can try to see what the picture looks like. All right, so first one we're doing is 3 plus 4 cosine of x over 5. So again, remember this number out front, just to be aware of the x here, that's a 1, right? So another way to write that is 1/5 times x, so that coefficient is a fifth. So just be aware. All right, so let's start with common misconception. I want you to take a moment and see if you can identify. You can even just draw an arrow if you want from that equation. What is the A, the B, and the C? I guess you can't draw an arrow because it's not on yours. But see if you can just label which one is the A value, which one is the B value, and which one's the C value. So take a second and see if you can label those. Just pause the video and do that. All right, so this is the part that people get kind of mixed up, but the A value is the 4. It's what's multiplied with the cosine. A lot of times people just kind of scan, and the first number they see, they think it's A. But the first number you see is not A. It's the thing that's being added. That's the C. So be super cautious. And then your B value is this 1/5. That number multiplied with the x. So be cautious. Make sure we know what we're identifying. All right, so amplitude then, that's coming from the A value. So here's our amplitude. It's a positive 4. So that means that that vertical shift, it's stretched. It's 4 times as tall as what it was before. So that's a vertical stretch. Is it reflected? We can do it at the same time. It's not negative, so that's a no. It's going to do its normal shape. It's going to go starting at a maximum because we're doing cosine, so it's going to be a max still. Let's talk about vertical shift. That's what's next in our list. That's our C value. So this is a positive 3. Note the number here. It's a positive 3. So that means it's going to be a shift of 3. If you say positive 3, I'm going to assume that you mean up. Some people want to actually say 3 up. Some people do a 3 with a little arrow. Whatever you need to do to help you remember that the entire graph is going to go up 3. So that means our new middle, like the new middle of the graph, is going to be happening at y equals 3. Remember, horizontal line, y equals a number, that's where the new middle is going to be. So instead of being at y equals 0, which is where all the graphs are traditionally, we're going to move it up 3. So the new middle of the graph, that's called the midline. All right, and the last little calculation we need to do is for period. Our b value, remember, is what's multiplied with the x, or the theta, whatever they're using for an angle. That's 1/5. Now remember, we have to do a little calculation here. The period formula is 2 pi divided by b, which is 1/5. So we need to remember how to do this now. How do you divide by a fraction? Well, you multiply by the reciprocal. So wow, that looks like that's going to be 10 pi. Wow, this thing is stretched out. The period, 10 pi. Normally it's 2 pi. Now it's 10 pi. So this thing is 5 times longer than what it was originally, because we only get through, remember what b means, 1/5 of a cycle in 2 pi. So when we think about what that's doing, this is going to be really stretched out horizontally. All right, I think we have everything we need. So we have to set up our scale to be appropriate for this new graph. So notice the x and y axis that I did. I didn't put the x-axis in the middle. I kind of put it lower on the graph because this entire graph is shifting up. So I need to think about where my graph is going to start, and that affects the picture that I'm going to be making. So let's put in some of the information. Let's start with doing our scale on the bottom. So we have our period number set up. So I'm going to start with the x-axis and see if I can get some numbers there. So remember, the end of your graph is always going to be your complete period. So I'm going to break this into 4. So I think I'll go, do I have enough to go every other? I think I do. So 1, 2, 3, 4, 5, 6, 7. There we go. Okay, so I'm going to still do it in quarters. Just so my graph isn't super tiny, I'm going to stretch it out just a little bit here for my labels. So this is going to be our 10 pi. Remember, that's your complete endpoint here. So this is our 10 pi. Now, remember how we do in our calculations. In the middle, then, the midpoint is half of 10 pi. So that's just kind of this yellow box here is kind of our thinking, our scratch work. So half of 10 pi would be 5 pi. And then we can do our first quarter. Well, that's going to be a quarter of the 10 pi. Another way to think of that is half of the 5 pi. Well, what's half of 5 pi? Well, it's 5 pi over 2. So you can just do half of that middle, or again, just do your scratch work. So 10 pi over 4, and then you can reduce, right? That would be 5 pi over 2. It's the same thing. In other words, 2.5 is half of 5. All right, so how do we find the third quarter? Well, we do 3/4 of 10 pi. So it's the 3/4 mark. Otherwise, we can just start counting up. So we'd have 5 pi over 2, 10 pi over 2, 15 pi over 2. So you can kind of just count up if you want to do it that way or just do the arithmetic. So that would be 30 pi over 4, which is most definitely 15 pi over 2. So sometimes getting the labels is the trickiest part for people on that period numbers. But again, it's just we're dividing it by 2, and then we're cutting it in half again, and then we're figuring out what that 3/4 point is. So it's always the same setup. It's always a half and a quarter and 3/4 because we're dividing it into four chunks. All right, so let's do the vertical scale. Now, normally we would just do our amplitude numbers and make sure we're okay with that. But here's the deal. Not only do we have an amplitude of 4, so this graph goes from +4 normally down to -4, but we have to shift it up. Okay, so I want you to think about your max and min points where they would have been before. So the max would have been before at +4, and the min would have been at -4. That's what an amplitude of 4 means. If you shift that graph up, that means each of these are going to be 3 higher than where they were before. Well, 3 higher than 4 is going to mean I have to be up at 7, and 3 higher than -4 means I'm going to have to be up at, let's see, what, -1? So I'm actually going to have to keep that in mind when I'm doing my vertical scale to be able to see things correctly. So let's go ahead and set that up. That means I'm going to have to go up to 7. So I'll go ahead and label here. Notice how nicely this is set up for you. You're going to have to think about that on your own, though, when you're doing yours. So think about what your amplitude is and what your vertical shift is, and figure out where your max and min points are going to be so you can plan ahead. The other thing I'm going to encourage you to put in your graph, and I'll look for, is your midline, that y equals 3. So I'm going to go ahead and put this in as a dash line. This is not like part of the graph. This is like your new sort of modified x-axis. So this x-axis right here, I am moving and showing my vertical shift. Remember, we went up 3, so this is actually the physical showing the up 3. I'm going to put that new middle so I can see where this graph is going to be attached from. So instead of being at 0, it's going to go up 3. All right, so now we're ready to graph. Cosine, remember, think about your parent graph here. I'm just going to scooch down for a second. Cosine, when we think of our 4 quarters, those 5 critical points starts at the max, middle, min, middle, max. That's our shape for cosine. So that's what we're going to do here when we graph. We're going to start at the maximum, right? So at 0, it's going to be at its max. But now we're not at 0 starting, we're at 3, right? Because that middle shifted up. So our maximum has to be 4 above that. So 1, 2, 3, 4. Remember we said if it was at 4 before, when I go up 3 from there, it's going to be at 7. Then I go to the middle of the graph. So if you've noticed, I always say max, middle, and min, because once we start translating, those points shift. So where's our middle? Well, it's at 3. So at 5 pi over 2, this graph is going to be in the middle at 3, because remember 3 is our vertical shift. That's where that new middle is. All right, then we go down to min at the next one. So at 5 pi, it's at the min. Where was the min going to be? Well, down at -1. So at 5 pi over 2, we're at -1. Sorry, that's kind of over the label there. And then we go back to the middle. So 15 pi over 2, we're at the middle. And then at 10 pi, we're back at the max. So this graph is going to look something like this. And remember, at the ends, make sure that you have the arrows going down, because remember our next point would be at the middle, and then the min, it would keep going infinitely in both directions. So we did a whole bunch of shifting here, right? So let's kind of put in the labels so we can see, and at least I'll do it on my graph. So the length of one complete period, remember that's our period, that's your 10 pi, that's the period value. This right here is the amplitude, so I'm kind of marking mine up so you can see. The amplitude is 4, so the difference between 3 and 7, yep, amplitude here is 4. That's what we mean when we have an amplitude number of 4. It means the distance from the middle to the top or the middle to the bottom is 4. The entire height of the curve, top to bottom, is 8. But remember, we take half of that to find the amplitude. So that 4 number is represented, that distance from the middle to the top or bottom. And then that vertical shift, we already kind of labeled that, or I did in my graph. That's that C value right here. We shifted everything up, so all those points moved. Excuse me. So that's kind of what we do for the vertical shift. Everything else is the same, but the entire graph moves either up or down. All right, so let's try one more and just make sure we're doing okay. We'll do a sine graph that has all of those transformations as well. All right, so here's what I'd like you to do. I want you to pause the video and write down the A, the B, and the C, or identify those, and try to see if you can fill in the chart below. The amplitude, is it reflected? What do you think the vertical shift should be? Where's your new middle? And what is the B value in the period? So see if you can get that information, and then we'll try to do the labels together. All right, so let's talk through the numbers here. So notice this one is written sort of in this second format. So remember that number, that C value can either be at the beginning or at the end. You need to look for the adding and subtracting. That's the key part of this, the plus or minus, to be able to see. So be able to see, get it? It's a C value. So make sure you're checking which one is which. All right, so let's see if we got the values correctly. The number out front, our A value, that's right here. That's going to give us our amplitude and whether it's reflected or not. So remember, your amplitude is always positive. So you really need to think absolute value of -2 or just the number part. What is that vertical stretch? Well, it's 2. So if somebody asks you what is the amplitude, you would have to say 2. But what does the negative mean? It is reflected. So this graph will be reflected over the x-axis. So that's the first one today, like that. Let's talk vertical shift. What is our C value? Well, C is the -1. That's that -1. So the vertical shift is -1. And if you say -1, I'm going to assume that you mean down. So some people might say down 1. Some people might say with an arrow just to remind themselves. But when you say -1, you mean the entire graph is going down 1. So instead of being at y equals 0 for the middle, my midline is y equals -1. Remember, this is a line. It's like where the new x-axis is. So it's like a horizontal line. Normally they're at 0. Now it's going to be down at 1. All right, let's talk the B value. Which number is the B value? What's multiplied with the X? Well, that's the 3. So trying to color code here. So B is 3. So remember, we have to do a calculation here, though, for period. So period is 2 pi divided by B. So 2 pi divided by 3. Not much to do there. It's 2 pi divided by 3. So normally, this graph happens in 2 pi. Now it's going to happen in 2/3 pi. So this is actually a horizontal shrink. This graph is shorter than what it was normally. In other words, we can get 3 complete cycles in 2 pi. That's what that means. So this is really condensed. There would be 3 of them in the space that there was normally 1. So that's what they're saying when you do a cycle, a B of 3. So that's kind of what you're thinking of when you do those. All right, so we have all our information. Gosh, now we need to set up our axes and see what we need to do. So let's take a peek and notice the amplitude is 2. So we're going to have a little vertical stretch, and then we're going to need to account for a down 1. So let's see if we can kind of think ahead here. So the max of this graph would normally be at 2. We're talking about amplitude here, and then the min would be at -2. So we have to adjust and kind of think ahead. Our vertical shift is down 1. So where is that going to put us? So 2 minus 1, that means our max is going to be at 1. And our min, -2 minus 1 more, would be at -3. So we just have to make sure when we're thinking about our vertical, we're going to need to account for that. So I guess I'll do that vertical scale here since we just talked about it. So that means I need to make sure I'm up to 1. Well, that shouldn't be too hard. And then I have to go down to -3 to account for that vertical shift and my amplitude. And then I'm going to go ahead and put in that new middle, my midline. That's at -1. And I'm just going to put it in as a dash line so everyone can see where that new middle is attached to, so I can see those values. So again, this vertical shift, here's your down 1. That's what we're saying from that 0. All right, now we need to do our amplitude here. Our period values. Need to figure out what's happening for these. So the end of our period is 2 pi over 3. That's that last number. And then we're going to have to figure out what each of those are going to be in between. So I'm going to go ahead and do 4 intervals. I know there isn't anything marked here for you, so we're going to figure out our markings ourselves. Just space them evenly as best you can. So we have our 2 pi over 3 at the end. And we're going to have to figure out our values from there. All right, so the midpoint. So we're going to figure out what would the middle be. So we're going to try to see if we can label these. So let's see, half of 2 pi over 3. Well, half of 2 pi over 3 would be 2 pi over 6 or pi over 3. So half of 2 of them would be 1 of them. Kind of makes sense. All right, then we need to do the quarter. Now, we can, again, do 1/4 of 2 pi over 3 works great. You can also just take half of pi over 3. So if I'm at the middle, the quarter is going to be half of that. So half of pi over 3 would be pi over 6. Also, you can, again, just do 2 pi over 12, 4 times 3, and then just reduce pi over 6. So whichever way is easier for you to do your calculation. Doesn't matter to me, but it's always quarter, 3/4, half every time. All right, so 3/4, so my third tick mark here, 3/4 of 2 pi over 3. I just count up. So 1 pi over 6, then that would be 2 pi over 6. So this next one would be 3 pi over 6. But what's 3 pi over 6 the same as? Can I reduce that a little bit? 3 pi over 6 would be the same as pi over 2. So I guess if I were going to be labeling this third quarter here, I would be labeling it pi over 2. We want to simplify if we can. So if we think about what's happening there. So try it on this version. So that would be 6 pi over 12. Then just reduce 6/12, that reduces to 1/2, so pi over 2. Again, whichever way is easier for you. Some people really like the 1/2, 1/4, 3/4 because they can just do that calculation. All right, so we've got our scale set up. We're ready to graph. So sine, let's think about what the graph for sine looks like. So look back if you need to, otherwise think about your parent graph where sine starts. So we're thinking about the normal graph. Starts in the middle, goes to the max, then the middle, the min, and back to the middle for our 5 critical points. So that picture for sine normally does this. All right, so let's see if we can figure out what our sine graph is going to do then. So we start at the middle, always. And where's our middle now, though? Well, it dropped down 1. So the middle of the graph is down at -1. So my middle is going to be right here. So that's my first point. Now, normally sine goes up, right, to its maximum. Here's where we have to take into account that it's been reflected. Instead of going up to a max, this graph is going to be reflected and it's going to go down first and then up. So when we reflect, that's what happens. Everything is going to be flipped in sine. So at pi over 6, instead of going up my amplitude value, I'm going to go down. So remember where mins are supposed to be. They're supposed to be at -3. So at pi over 6, we're going to be down at -3. Notice 2 away, so 1, 2 away from that new middle. And it's going down because it's reflected. Okay, so where does it go from the min? It goes back to the middle always. And then it goes to the max, because remember it's reflected. So at pi over 2, we're going to go up to from that middle. Now remember, we said our maximum is going to be at 1 now because the graph shifted down 1. So it's still going to be 2 above the middle, but that's going to be a positive 1, and then we're back to the middle at 2 pi over 3. So we're going to connect with a nice, smooth, continuous curve here. And we have our nice reflected sine graph. So we have an amplitude of 2, just kind of put in the numbers here so you can see. You don't have to draw them on your picture if you don't want to. There's your amplitude of 2. So distance from the middle to the top or bottom, that's a distance of 2. My period, the length of one complete graph, remember 1 cycle, that's the 2 pi over 3. That's how long that graph is. And then that vertical shift we already talked about is our down 1. So our new middle was at -1. And that's all there is to it. When we take a look at those graphs, the A, the B, and the C, we have our amplitude values, always positive. If it's negative, that means it's reflected over the midline. Then we have our B value, which tells us something about the length, how many cycles. Normally the period's 2 pi. We do 2 pi over B. And then our C, that shifts or translates the graph either up or down. If C is positive, graph goes up, and if C is negative, it goes down.